Hi everyone, welcome to the session on Internet of Things on Module 5, IoT Physical Devices and Endpoints. Today we'll be discussing how to access the temperature data from a temperature sensor and display it on the terminal. This is Sharath Kiar, Assistant Professor in the Department of Computer Science and Engineering, STMIT Ujjain. Let's get started. So in today's session, we'll see how to write a program in order to record a temperature from DS18B20 sensor and display the data on the terminal. So this could be done in two ways. So the first way is by accessing the temperature data straight away on the terminal and by displaying it. Or the second way is by writing a program in order to access the temperature and display it on the terminal. The third way is that the temperature data upon accessing from the sensor would also be displayed on a LCD interface. So in today's program, in today's session, we'll discuss the first two ways in which how the program could be written in order to access the temperature from the sensor and display it on the terminal, and also by using the terminal straight away in order to access the temperature data and display it. So before going for the coding part, so we'll try to know what is DS18B20 sensor. So DS18B20 sensor is a temperature sensor that could be used in order to access the temperature, and it's being provided with this additional functionality that it has an alarm function that could be configured whenever the temperature exceeds or becomes low with respect to the threshold as set by the user. So this sensor is basically used in order to access the temperature data, and it is best suited for the projects like weather monitoring and home automation systems. This sensor is most commonly recommended because of its accuracy, and the readings could be easily measured. And this temperature sensor basically measures the temperature data between minus 55 degrees Celsius to 125 degrees Celsius, and it requires an operating voltage of 3 to 5 volts. So the following figure shows the connection of DS18B20 sensor with respect to the Raspberry Pi kit. As you can see, there are three different pins with respect to this DS18B20 temperature sensor. So one is a ground pin, which is connected to the ground pin of the Raspberry Pi kit, and VCC is connected to one of the GPIO pins, and the data is connected with respect to the resistor. And resistor is being added in order to ensure that there is no faults that happens because of the exceeding voltages. So basically, resistors are added in order to in order to provide support for fault tolerance. So coming to the first way in which the code could be written straight away using the terminal. So the first thing is, so there are certain sensors which requires the configuration to be done even before the sensors can be used, and this DS 18B20 sensor also requires the configuration to be done even before it can be used for accessing the temperature data. So let's now look at the steps in which the configuration could be done. So initially, uh, we have to configure the configuration file, and this can be done by writing the command as sudo nano /config.txt. So opening the configuration file in the super user mode, we can open the configuration file, and once the configuration file is opened, so you have to add this particular line, so which is data overlay is equal to w1-gpio. So this statement has to be added at the end of the configuration file which we have opened, which ensures that the W1 protocol would be enabled. So W1 protocol is basically a single wire protocol, because this sensor contains a single wire through which the data could be accessed. So once this line is added to the configuration file, so now in order to ensure that it is being added, we have to reboot it. That could be done by using the command sudo reboot, and once if everything goes right in the prompt, so once upon writing the command, if we get the next command line prompt, it means that the command was successfully executed without any errors. So otherwise we would get the errors on this corresponding terminal. So once it is rebooted, so then we have to add this corresponding sensor device with respect to the Raspberry Pi kit. This could be done by executing two different commands, which is called as mod probe w1-gpio and mod probe w1-therm. So this basically adds the this corresponding sensor device with respect to the Raspberry Pi kit. And in order to ensure whether the device is added or not, so then we can go to the corresponding directory in order to check with respect to the devices folder. So therefore, we have to change the directory to devices folder, and the corresponding path would be system/bus/w1/devices. And once we go into this corresponding directory, then we'll list all the files that starts with uh, 28 hyphen followed by the sensor ID. So upon executing the ls command, it gives a list of files which starts with the 28. Which gives all the files, and we are interested in only those directories which begins with 28. So once this is done, so this is what we have shown in this following figure. So we have added the device, and we have changed to this corresponding devices folder, and we have found this corresponding directory which starts with 28. And once this is done, so now the temperature device sensor is ready to be used. So now we can access the temperature from the device since the device is ready. And in order to display the temperature data, we can use the display command, which is cat w1_slave. So it displays two different lines of data that is being accessed, which is considered to be the raw data. And as you can see in the second line, so T is equal to 32768 would be the temperature data that was given by the sensor. And to put this in appropriate Celsius format, we have to divide this by 1000. So it means that the temperature is 32.76 degree in Celsius. Of course, the temperature data could also be displayed in terms of Fahrenheit. So this is the first way in which we can use this command prompt or the terminal in order to access the temperature data just by running these following commands. Or on the other way around, we can also write a program in order to access this temperature data. Going to the second method, so we'll write a program in order to access this corresponding temperature data from the sensor. So the first step, as usual, setting up with respect to the root file and importing the necessary packages. So since we are using the interrupt, so operating system package is required, and we also import the global variables. And since we are using time delay, we are also using this time package. And the first thing, so here in the first part of the code is the same configuration that I've already explained here. So these are the following steps that has to be also done with respect to the programming part. So first thing is, we'll set up the device, and this could be done by running these two lines, that is mod probe w1-gpio and mod probe w1-therm. And it is a system command, so therefore we use os.system. And then once upon adding this device, so we open the corresponding base directory with respect to this devices folder, and we'll make the base directory as /system/bus/w1/devices. And once this devices folder is accessed, so then we are looking for that particular directory which begins with the 28. So as you can see here, we have used 28 star, so it means any directory which begins with 28, all those directories would be accessed. So here we are using the pattern matching. And once the corresponding directory which begins with 28 is accessed, so we look for the file w1_slave where the temperature data resides. So once this is done, now we are ready to access the temperature data. So we write a user-defined function called read_temperature_raw, wherein we open this device file in the read mode, and we use a built-in function called readlines in order to access these two lines from the sensor. So these are the two different raw data that is being accessed by the sensor. And these two lines, once accessed, it is stored under a variable called lines. And once these two lines are accessed, the file is closed, and these two lines are returned back. So coming to another user-defined function called read temperature. So here, first thing is we have to access those two lines, and for that we have written a user-defined function which I explained just now, wherein we read the temperature data which is raw in nature. So once these two lines are accessed, so then we will introduce a very small delay, and now it's a time in order to display the temperature. As you can see, once these two lines are accessed, you can find that the temperature data is found on the second line. So we are interested only in this part of the data. The other part of the data is not really required. So now let's see how to access that second line temperature data. So for that, we'll try to find the my index position of where this t is equal to is found. So for that, we use the function find function in Python, which returns the index where this t equal to is found. And as you can see, this t equal to is found in the second line. Therefore, we are accessing only the second line, that is lines of 1. So lines of 1 find t equal to, so which returns the corresponding index, and this index would be stored under a variable called equal position. And if this equal position is not equal to -1, so it means that this corresponding index was found. If this index was not found, then probably this find function will return -1 as its value. So assuming that since t is equal to is found, appropriate index would have been sent to this equals position variable. And now since equal position index value is not equal to 1, we'll proceed further. So now, so going to the second line, so we are interested in only the temperature data. As you can see, this index is being known, and the index next two positions would be the actual data, right? So we need to traverse across the next two positions upon this index. For that reason, for this corresponding index, we'll add two more, so that the appropriate data that we are looking for temperature is accessed. So now once this temperature data is accessed, we'll convert that into a decimal form, and then we'll divide that by 1000, so that we can put the temperature in the form of Celsius. So once this data is ready, now we can print. So however, we are using the infinite loop, wherein we are regularly accessing the temperature and printing it on this terminal for every 1 minute. So thank you.